Jupiter, the fifth planet from our Sun, is a true giant, a colossal presence in our solar system. It dwarfs all other planets in our solar system, making them look like mere specks in comparison. Its swirling clouds of gas and dust hide a colossal world, a world that is both fascinating and mysterious, a world of storms and mysteries where the unknown beckons to be explored. Jupiter is composed mainly of hydrogen and helium, the two most abundant elements in the universe. These are the lightest elements in the universe, yet they form the bulk of this massive planet. They are also the building blocks of stars, the very essence of stellar creation. Jupiter's mass is over 300 times that of Earth, making it the heavyweight champion of our solar system. This massive size creates an incredible gravitational pull, a force that dominates its surroundings. Jupiter's gravity affects everything around it, from tiny particles to massive moons. It shapes the orbits of comets and asteroids, acting as a cosmic shepherd. It even influences the paths of other planets, subtly altering their courses. Despite its size, Jupiter spins incredibly fast, completing a rotation in a fraction of the time it takes Earth. It completes a rotation on its axis in just under 10 hours, a remarkable feat for such a giant. This rapid spin contributes to Jupiter's iconic bands of clouds, which are a defining feature of the planet. These bands move at different speeds, creating a dynamic and ever-changing atmosphere. This creates powerful storms and turbulence in the planet's atmosphere, adding to its dramatic and volatile nature. Jupiter is a breathtaking example of the raw power and beauty of our universe, a testament to the wonders of the cosmos. Our Sun is a star, a giant ball of burning gas radiating light and heat. It is the center of our solar system, the heart that keeps everything in motion. All planets orbit the Sun, held in place by its immense gravity, a force that binds the solar system together. The Sun's energy comes from nuclear fusion, a process that happens deep within its core, where temperatures soar to millions of degrees. Hydrogen atoms fuse together under intense pressure and heat, creating helium and releasing a tremendous amount of energy in the form of light and heat. This energy radiates outward from the Sun, traveling through space as light and heat, reaching planets and moons. This energy is essential for life on Earth. It warms our planet, drives our weather patterns, and influences our climate. It provides the energy for plants to grow, fueling the food chain. Without the Sun, our planet would be a frozen, lifeless rock, drifting aimlessly in the cold void of space. The Sun's mass is about 333,000 times that of Earth. This immense mass creates the gravitational pull that holds our solar system together, ensuring that planets, asteroids, and comets follow their paths. The Sun's energy and gravity are fundamental forces that shape our corner of the cosmos, making life possible. We stand in awe of these celestial giants, Jupiter, the massive planet, and the Sun, our life-giving star. This begs the question, what if our giant neighbor Jupiter became our Sun? It's a captivating thought experiment. Could Jupiter, with its massive size and composition, ever ignite into a star? To answer this, we need to delve into the heart of how stars are born. We need to explore the fundamental processes that make a star shine. Stars are not simply large balls of fire. They are cosmic furnaces powered by nuclear fusion. This fusion requires immense pressure and heat. These conditions are found deep within the core of a star. For a celestial object to achieve nuclear fusion and become a star, it needs to have a certain minimum mass. This mass is critical. It determines whether gravity can create the conditions needed for fusion to ignite. The minimum mass required for a celestial object to ignite nuclear fusion is about 80 times the mass of Jupiter. This is a significant amount of mass. Jupiter, despite its size, falls short of this critical threshold. Our Sun, on the other hand, is a true star. It possesses the necessary mass for nuclear fusion. Its core is a raging inferno of nuclear reactions. These reactions produce the energy that lights up our solar system. If we could somehow magically add mass to Jupiter, could we turn it into a star? Let's imagine for a moment that we have the power to manipulate the cosmos. Let's explore what would happen if we could artificially increase Jupiter's mass to the point of stellar ignition. Section 5. A hypothetical ignition, Jupiter as a red dwarf. If we could somehow add enough mass to Jupiter, it could theoretically ignite into a star. However, it wouldn't be a star like our Sun. It wouldn't possess the same brilliance or energy output. Instead, Jupiter would likely become a red dwarf star. These are the smallest and coolest type of star. They emit a faint reddish light. They have a much lower energy output compared to our Sun. Even as a red dwarf, Jupiter's transformation would have profound effects on our solar system. The gravitational dynamics would shift dramatically. The orbits of planets would be thrown into disarray. Our solar system, once a place of relative stability, would be plunged into chaos. Section 6. Gravitational upheaval, the solar system in chaos. If Jupiter were to become a star, even a small red dwarf, its increased gravity would disrupt the delicate balance of our solar system. This transformation would have profound consequences for every celestial body within our solar neighborhood. The orbits of planets would be altered dramatically, causing a cascade of changes. Some planets might be pulled closer to the newly formed star, experiencing intense heat and radiation. Others might be flung out of the solar system entirely, lost to the vastness of interstellar space. Jupiter's moons would be the first to experience this change, facing immediate and severe gravitational shifts. Their orbits would become unstable, leading to unpredictable movements. They would be at risk of colliding with each other or being ejected into space, creating a chaotic environment. Saturn, with its intricate rings and numerous moons, would also be significantly affected, potentially losing some of its moons or having its rings disrupted. The asteroid belt, located between Mars and Jupiter, would be scattered, sending countless asteroids on new trajectories. Asteroids would be sent hurtling through the solar system, creating a perilous environment. This would pose a significant threat to Earth and other planets, increasing the likelihood of catastrophic impacts. The gravitational ripple effects would extend throughout the solar system, affecting even the most distant objects. No planet would be immune to the changes brought about by Jupiter's transformation, leading to a solar system in complete chaos and upheaval. Section 7. Earth's fate, a frozen wasteland. Earth, our home planet, would face a bleak future if Jupiter became a star. Even a dim red dwarf would not provide enough heat and light to sustain life on Earth. Our planet would quickly cool down, temperatures would plummet, and oceans would freeze over. Earth would transform into a frozen wasteland. The once vibrant blue planet would become a desolate, icy sphere. The lack of sunlight would have catastrophic consequences for all life on Earth. Photosynthesis, the process by which plants convert sunlight into energy, would cease. Plants would wither and die. This would have a domino effect on the entire food chain. Section 8. Life without light. The collapse of ecosystems. The collapse of plant life would trigger a cascade of extinctions throughout Earth's ecosystems. Herbivores deprived of their food source would starve to death. Carnivores in turn would lose their prey and succumb to the same fate. The intricate web of life that exists on Earth would unravel. Entire ecosystems would collapse. The once teeming planet would become a silent, barren world. The oceans, too, would suffer the consequences of a darkened sun. Marine life depends on sunlight for survival. Phytoplankton, the base of the marine food chain, would die off. This would lead to the collapse of fish populations and other marine organisms. Section 9. Human endeavor, survival against the odds. Faced with such a dire scenario, could humanity survive? It would be a monumental challenge. We would need to adapt to a life without sunlight and the natural resources we depend on. Underground bunkers, powered by geothermal energy, might offer some protection from the harsh conditions on the surface. We would need to develop sustainable food sources, perhaps through hydroponics or other forms of artificial agriculture. Space exploration and the search for habitable planets would become even more critical. We would need to find a new home for humanity among the stars. The survival of our species would depend on our ingenuity, resilience, and determination. It would be a race against time and a testament to the human spirit. Section 10. A binary dance. 2 stars in our sky. Let's imagine a slightly different scenario. What if Jupiter became a star, but our sun remained as well? We would have a binary star system with 2 stars orbiting a common center of mass. This would create a celestial dance of incredible beauty and complexity. The gravitational interactions between the 2 stars would be fascinating to observe. The orbits of planets in this binary system would be highly elliptical. They would experience extreme temperature variations as they moved closer to and farther away from the 2 stars. Earth, caught in the gravitational tug-of-war between 2 suns, would likely be uninhabitable. Section 11. Appreciating our place in the cosmos. The thought experiment of Jupiter becoming a star highlights the delicate balance of our solar system. It underscores the importance of our sun for life on Earth. Our sun is not just a star, it is the lifeblood of our planet. It is the source of our energy, our climate, and our very existence. We often take the sun for granted, but it is a celestial wonder that deserves our awe and appreciation. What did you think of this cosmic journey? Share your thoughts in the comments below. Don't forget to like, subscribe, and hit that notification bell for more explorations of the universe. Next time we'll delve into the mysteries of black holes.